All right, today we will be covering lesson 18-3 on triangle proportionality theorem. This lesson will be split into 5 separate sections. They will cover questions 1 to 4, question 5, question 6, question 7 to 8, and then we will round it out by covering questions 11 to 12. So let's go ahead and take a look at our introduction for questions 1 to 4. Clarissa needs to find the distance across a lake in the national park. She locates points A, B, C, D, and E and takes the measurements shown. She thinks she can use similar triangles to find the distance. It says if MR is parallel to ST in the figure below, explain why triangle MAR is similar to triangle SAT. 2 states, knowing that corresponding sides of similar triangles are proportional, complete this proportion. AM over AS equals AR over blank. 3. If AM is 12 centimeters, MS is 9 centimeters, and AR is 15 centimeters, determine RT and show your work. 4. If MS is 8 centimeters, AR is 25 centimeters, RT is 10 centimeters, determine AM and show your work. For this particular section, I'm going to go with 8 minutes to answer questions 1 to 4. Go ahead and pause your videos now and work through questions 1 to 4. As you can see, questions 1 through 4 have now been marked for us. I stated, well, because we know that MR is parallel to ST, we can state that angle AMR is congruent to angle AST because corresponding angles are congruent when 2 lines that are parallel are cut by a transversal. So corresponding angles congruent. And we know that angle A is congruent to itself because of the reflexive property. So I stated that. Well, I know that the angle of two angles of MAR are congruent to 2 angles of SAT, so I can state by angle-angle similarity. Well, here in question 2, it says AM over AS, so small triangle to large triangle, is equal to AR, which is in the small triangle, over AT, which is in the larger of the 2 triangles. I plugged in pieces for question number 3 that I knew. If we know AM, that's the top position, right, is 12. The bottom position is AS. Well, if we know that this is 12 and this is 9, that full piece is 21, and you'll come to see me write that down a little later in the problem. AR was 15. We're looking for RT, so that's an unknown here. So notice that whenever I wrote the denominator, I wrote 15 plus RT because I don't know what RT is. So I had to use the distributive property here. So I had 12 times 15 was 180. 12 times RT is 12 RT. 15 times 21 is 315. We would have used the subtraction property here. I would have subtracted 180 from both sides. Got 12 RT equals 135. Did the division property to find that RT was equal to 11.25 centimeters. I worked a very similar process for number 4, except in number 4, AM was your missing piece. So that came up twice. It came up in the small triangle and in the large triangle. So we said AM over AM plus 8 equals 25 over 25 plus 10. I did the addition combining these like terms right here. So that gave me 35 times AM whenever I did my cross multiplication. And then I had 25 times AM plus 8. Then I had to do the subtraction property with my 25 AM after I did the distributive property up there. That gave me 10 AM equals 200 and divided by 10 to get AM equal to 20 centimeters. On to the next set of problems.